Welcome back to the MOVI-C Control Cabinet Products Basic to Intermediate Training. This is Session 2. We introduced the basics back in Session 1, and now we're going to move into some specific details about MOVI-C Control Cabinet Product VFDs. So we're going to take a look at some of the major branches and their capabilities so you know your way around the product. Let's start with a big idea that's important. If you're familiar with our previous generation products, what we call the B generation, most of those were rated in kilowatts. That may seem a little strange in the United States since we tend to use horsepower when we talk about mechanical power and kilowatts for electrical. In the European world, they use kilowatts for everything. So a lot of the MOVIDRIVE B, for example, products were rated in kilowatts. But we've changed that with the MOVI-C VFDs. They are rated in amperes, so you're going to see amps a lot more than you'll see kilowatts. There is one exception to this, and that's power supply modules, which are still rated in kilowatts, which kind of makes sense. Let me also introduce something else which isn't directly MOVI-C, but it's very important to MOVI-C products, and it's a new product that SEW MOVIDRIVE has introduced alongside MOVI-C. It's something called digital motor integration. What is digital motor integration? Well, I informally call it kind of a plug-and-play motor. It means that the motor has some intelligence inside its conduit box that knows a lot about the motor, and it communicates to the VFD over a special hybrid cable. When you take a motor with this capability and you plug it in with the right cable to the VFD, it communicates information about itself. And it does it over this special little purple cable that's inside the hybrid cable. Now, the hybrid cable has the usual 3 motor phases. It's got the ground wire. It's probably got some brake wires and other things. But it's got this little purple cable, which is a coaxial cable. This tiny coaxial cable carries a digital data stream that communicates from the motor directly to the VFD. And it can communicate things like motor startup data. It can communicate what we call an electronic nameplate, where the motor says, I'm this kind of motor, I run on this voltage, I run at this speed, I have this torque, I have these characteristics. So in other words, the VFD can pretty much do almost an automatic startup if it's communicating with one of these motors. If there's an encoder, it can communicate over this cable, it can communicate thermal data. If there are sensors like vibration sensors, they can talk over it. So we call this technology overall DDI, which is really kind of a shortened form of MOVI-Link Digital Data Interface. It's the communication connector on the VFD that connects to this cable and communicates with a DDI-capable motor. This is something relatively new. We're very excited about it. I was eager to play with it, and I got my hands on a DDI motor just recently, and it's just as good as they claimed it is. So this is really kind of a game changer and something that will be making startups and configuration a lot quicker and easier. So you'll hear me mention DDI occasionally. That's what it's all about. Let's start with MOVIDRIVE technology, since that's the product we're going to focus on in this class. It's also in many ways one of the core products in the MOVI-C Control Cabinet product line. It comes in 8 sizes. They support currents up to 588 amperes. The smallest is 2. So that ranges from something for a very small motor to something up to a very large motor. They have a feature called Safe Torque Off built in. Safe Torque Off is a feature that prevents the motor from turning. It is a kind of safety device. If Safe Torque Off is triggered, the VFD will not allow the motor to develop torque. It won't turn and potentially crush somebody. Now, let me emphasize this. Safe Torque Off, or STO, is not lockout tagout. It doesn't electrically immobilize the drive, so the drive is still energized. It could still shock you if you touch the wrong place, but the motor won't develop torque. On top of the VFD, if you look at the picture on the right, you'll see a little connector. That is a safe torque off jumper connector. The drive is shipped with that. It's in place. If it's in there, then safe torque off is disabled. So if you don't want to use it, just leave the jumper installed. But if you want to connect up a safe torque off circuit, you can remove that, put a connector in its place wired up to a safe torque off circuit, and if that gets triggered, it will immobilize the motor so it can't turn and develop torque. So that is a feature not all VFDs have, but MOVIDRIVE technology definitely does. It contains a built-in communication system meant to communicate with some types of controllers. It's based on a standard called EtherCAT. EtherCAT is an industry standard. It's sort of like Ethernet, but it has some features that let it communicate in real time. SEW runs its own custom protocol over EtherCAT, which we call SBus Plus. So we often use these terms paired together. Ethernet is the industry standard. It handles communication. SBus Plus is like SEW communications over EtherCAT. And there is this feature in MOVIDRIVE technology. MOVIDRIVE technology comes with a built-in field bus card. This is a standard feature. It's not something you have to pay extra to add in. There are 3 choices. We support many of the common modern field bus standards and one legacy field bus standard as well. There's a built-in encoder interface to work with motors with encoders. That's a type of feedback. Again, this was often an add-in with older products, but it's just built in automatically with MOVIDRIVE technology. And the nice thing about it is it communicates with many different types of encoders. We support multiple encoder standards. There's the DDI interface for those digital motors as well. So if you buy an SEW DDI motor, you can plug it into that little tiny connector there, and that digital data stream will be available to the VFD. It accepts keypads, and you can see 2 keypad styles in these pictures. The one on the left is the high-end full-color keypad. The one on the right is a smaller monochrome keypad that has less capabilities but also costs less. So we offer keypads that can be used. These can be used to help engineer the drive. They can be used as status displays. They can be used for diagnostics. We will do an activity before this course is over where I show you what you can do with the keypad. We'll be using the full color one that you can see on the left. There are 2 expansion slots in the VFD that accept expansion cards. These allow you to augment its capability. For example, you could put an I/O card in there that would give you extra I/O. There are functional safety cards. There are cards with an extra encoder connector on there if you need 2 encoders for some reason. Lots of capabilities. We give you a generous amount of expansion. But even the built-in capabilities are really good. We have a lot of built-in I/O, input-output. We have 8 digital inputs and 4 digital outputs. We also have a built-in programmable relay contact that can drive other circuits. MOVIDRIVE technology out of the box has a lot of capability, and in many cases, it's all you'll need for your application. It's really a nice product. Now, MOVIDRIVE technology devices can operate in standalone mode. You don't have to connect them really to much of anything else. You could, for example, connect them up just to some switches and maybe some indicator lights and control an application. We'll be doing a lab where we control a MOVIDRIVE technology in that way. It's called terminal control mode or binary mode. That is possible. Or you could connect them up to a PLC that's got some digital inputs and outputs, contacts that it can open and close, and you could run the VFD in that way. That's a very simple way of controlling it. So you can definitely do basic things with it if that's all you want. However, since it has a built-in field bus card, you can go well beyond that. And so commonly what we envision is that you're going to connect a MOVIDRIVE technology or a group of them to a field bus using the built-in field bus card, and they'll be talking to a PLC made by one of the very common PLC manufacturers. Companies like Allen Bradley, Rockwell, Siemens, and they can talk over that field bus to our VFDs, controlling them, telling them what to do. So we have a lot of flexibility here, ranging from just very simple basic operations to very sophisticated operations. It's all possible with MOVIDRIVE technology. These are the field bus standards we support. We support Ethernet IP, Modbus TCP, and Profinet. Those are all Ethernet-based field buses, but we support one legacy field bus standard as well, and that is Profibus. That one goes back several decades. It's been around for a long time. It's obviously less sophisticated, but there are a ton of things out there still using it, so we still support it. So you've got these choices. Field bus communications is definitely something that is well covered with MOVIDRIVE technology. All right, now let's move up the ladder to MOVIDRIVE system. This is kind of our next rung on the MOVI-C control cabinet products ladder. MOVIDRIVE system looks a lot like MOVIDRIVE technology. In fact, it has a lot of the same specifications. It's got exactly the same sizes 1 through 8. They go from about 2 amperes to about 588. They have safe torque off built in. They have that EtherCAT S-Bus Plus interface. They have the built-in multi-type encoder interface that talks to lots of different encoders. They have DDI to talk to those digital motors, and they have 2 expansion slots as well. So hardware-wise, they're very, very similar to MOVIDRIVE technology, but they have different internal software, and they have greater capabilities. So what's different? Their built-in I/O is slightly less. They have only 6 digital inputs, but they do have 4 digital outputs. They do not have the programmable relay, so the built-in I/O is slightly different, fairly similar, and they don't have a field bus card slot. Now you may be thinking, well, that's kind of bad. What if I want to connect them to a field bus? Well, just remember this. They're generally meant to work with a controller, and they get their field bus communication not directly, but through the controller, which has a field bus card. So that is the difference. They do have field bus communication, but they get it in a different way. So they typically require an SCW Eurodrive controller of some kind, and we make a variety of controllers in different sizes. There are ways you can run them without a controller, and I will talk about that, but typically they have a controller paired alongside them. How does this work? Well, this is kind of the idea. We have an SCW controller, that's the orange box on the left, and it's connected to what's often a chain of MOVIDRIVE system VFDs. And we link them all together with that built-in EtherCAT S-Bus Plus interface, which is on the top. You can see them all chained together, one into the other. And what the controller does is it operates all those VFDs. So think of the controller like almost a mini PLC. And so it's running things over that built-in EtherCAT communication system and controlling things. And then if you want to connect that up to your PLC, your Allen Bradley PLC, or your Siemens PLC, then what you do is you connect that to the field bus interface on the controller, and the controller then talks to the VFDs. So that's how we do field bus with MOVIDRIVE system. These are the standards we support. We support Ethernet IP, Modbus TCP, and Profinet. Those are all the Ethernet-based field buses. We do not support Profibus. That's the legacy one, so we don't support the legacy with MOVIDRIVE system. We only do that with MOVIDRIVE technology. Now we're moving up to the next branch of MOVI-C control cabinet products, MOVIDRIVE modular, which is kind of the very top of the tree. This product is a little different from the others. It is much more complicated and much more sophisticated, and it's also different from most of our existing VFDs. Now you may wonder, in what way is it different? Well, we're coming to that. It's actually like a previous generation product, which was called MOVI-Access. You may never have seen a MOVI-Access if you're in the United States. They weren't as common over here as they were in Europe. They sometimes were inside other pieces of equipment. Some OEMs use them, but that's really what it is. It's a successor to MOVI-Access in the MOVI-C world. It's an extremely powerful, versatile product. And the big difference is it's a multi-axis unit. That means that each axis can control an individual motor, and they can be different sizes, so you can control a whole range of motors. Usually you would use a MOVIDRIVE modular in a machine that's got a bunch of motors doing all sorts of related coordinated tasks. So maybe a big customized manufacturing machine that does all kinds of different things with multiple motors. That's generally what it's aimed at. So let's talk about how MOVIDRIVE modular is put together. First of all, a MOVIDRIVE modular unit has three distinct components. Rather than just the VFD itself, there are three things almost always together. The first thing is the power module. There's a central power module that powers everything. So all the VFDs share this power module, and so you've got to size that module to the appropriate size for what you're doing. Then attached to that, you have what are called axis modules, and they chain together side by side. They control either one motor, or there are double axis modules that can control two motors. And these come in different ratings for different size motors. So what you would do is assemble the axis modules for the motors your application needs. And then finally, there's a controller that operates everything. So all these things get chained together into a unified product. They are linked together by the SBus Plus, that EtherCAT interface, that handles communication. And then there are some very hefty bus bars that carry the high voltage DC from the power module to each individual axis module. That's what those three bars are. Two of them carry DC, one of them is a ground connection. And I would say this, they are under protective covers. If you ever take those covers off, do not come anywhere near these bus bars. Do not turn on the product because those are energized with close to 700 volts DC. So those will definitely be very dangerous if they're uncovered. So keep the safety covers in place. That is a MOVIDRIVE modular setup. The power modules that you buy for MOVIDRIVE modular can come up to 110 kilowatts. So they come in fairly large sizes for bigger motors. There are also smaller ones. They're the one product in the MOVI-C lineup that we rate by kilowatts. We also have what are called regenerative modules. They go up to 75 kilowatts. And maybe you're asking the question, what's regenerative mean? Well, think about this. If you have an electric motor, normally it's receiving electricity from the power supply to drive something. Let's say you have an application that when you shut it off, the load keeps the motor turning for a while. What happens when you do that is the motor becomes a generator and it starts making electricity that it pushes back into the variable frequency drive. Now you've got to do something with that energy. You can't just push it back in. It would actually damage the VFD. So you have to dissipate it in one of two ways. The most common way is to pass it through a big resistor that converts it to heat and then you just throw it away. It's wasted energy. A lot of VFDs do that just to get rid of it. But in big applications, that's a lot of energy. So it makes more sense to recapture it and do something with it. That is what a regenerative module does. It captures that energy that's coming back from the motor when it's running as a generator under the load that's turning it, and it stores it, and then later it can put it back in to the motor when you power up the motor again. So regenerative modules save energy. They recover energy that essentially happens when the motor is sort of slowing down. And they can return it to the line and then put it back in later. So in applications where you're trying to be especially green, regenerative modules are a great idea. Some people use them, some don't, but they're available. They don't come in quite as big a size as you can see, but they are out there. You can use, in theory, up to 15 access modules per power supply. Of course, you've got to make sure the math all adds up, that there's enough electricity to run those, but it is theoretically possible, so you can make some pretty big MOVIDRIVE modular setups. We also sell a 24-volt power supply module that powers the low-voltage electronics. If you already have 24 volts, you won't need this, but if you want 24 volts to be built right in, you can buy one from us. And then finally, we sell external capacitors, which are used with the regenerative system if you're using that. MOVIDRIVE modular access modules come in two styles. We have a single access module, which can run a single motor. Access modules come in sizes up to 180 amperes. We also sell a double access module. It's like 2-in-1, and it can control two separate motors. These don't come as big. They can go up to 8 amperes per axis, so they're really aimed at smaller motors. It's really like 2 access modules in one box. They can handle up to 250% overload for 1 second, so they're pretty durable. They have built-in safe torque off capabilities, like all of our MOVI-C VFDs that we've discussed. They too contain the EtherCAT S-Bus Plus interface for communications. They also support the multi-type encoder interfaces. You can see them in these pictures. They're on the front. They're that 15-pin D-shaped connector kind of near the bottom. You notice the double access module has 2, since it can handle 2 motors. And they do have DDI interfaces as well if you want to use them with our digital motor communications. Now, a little caveat here, the double access module does have an exception. You can get it either with DDI or the 2 encoder interfaces, but not both at the same time. The reason is the double access module just doesn't physically have the room to support all the electronics. So when you buy it, you pick, do you want DDI, 2 DDI interfaces, or 2 encoder interfaces, but you don't get both. But the single access module does have both. So do be aware of that. The double access modules have some exceptions, and I'll point them out as we go along. And then we have either 1 expansion slot in the single access module or 2 expansion slots in the double access module. The built-in IOs are similar to MOVIDRIVE system. You have 6 digital inputs and 4 digital outputs. Again, the double access module has a pair of those, so it would actually have 12 digital inputs and 8 digital outputs. You can see the connectors there side by side up near the top. All right, here's the general layout of a MOVIDRIVE modular setup. Again, in most cases, we have a controller, and it's controlling the motion through the S-Bus Plus, the EtherCAT that's built in. So this is the typical setup. You have the controller on the left, you have the power supply module, you have multiple access modules. It's all connected together with the EtherCAT S-Bus Plus. And if you need external PLC communication, it talks to the controller over one of these standard Ethernet type field buses. These are the ones we support: Ethernet IP, Modbus TCP, and Profinet. So you can see overall there's the same general picture. It is also possible to mix products from some of the MOVI-C control cabinet product lines. You could, for example, take a MOVIDRIVE system and group it with a MOVIDRIVE modular. You may wonder, why would I do this? Well, maybe you've got a situation like this. You've got a bunch of smaller motors being controlled by the access modules in the MOVIDRIVE modular, but you've got one gargantuan motor that needs a lot of amperes, bigger than the access modules can handle. So what you do is you buy a single large MOVIDRIVE system and maybe a few other things, and you connect them all together over the EtherCAT S-Bus Plus connection, hook it all up to the controller, and you've got one system with little motors and big motors. You can do that. It is very flexible, and that is yet another reason why this system is just so powerful. All right, now we need to talk about some exceptions. With SEW URODRIVE products, there are frequently exceptions, and I want to be sure you understand these. Now, I have mentioned repeatedly that MOVIDRIVE system products and MOVIDRIVE modular usually require an SEW URODRIVE controller, sort of like that small mini PLC. That is almost always true, but it is not universally true, and I want to explain the cases where you would not do that. So here is one way you can operate one of those two products without an SEW controller. There is something out there in industry called CIA 402. It stands for CAN in Automation. It is a type of control environment that uses Beckhoff products where a Beckhoff controller is talking to a VFD and taking full control over it and coordinating all the motion through the controller. It is possible to buy a MOVIDRIVE modular or MOVIDRIVE system setup designed to use a CIA 402 controller in place of the SEW controller. In fact, you can't use an SEW controller with these. You don't have it, you have the CIA 402 controller in its place. So it's kind of like this. We have here some MOVIDRIVE modulars. You notice we have the power supply and the access modules. We have some MOVIDRIVE systems of different types, but notice there's no SEW controller in this picture. Instead, there's a CIA 402 controller that somebody else manufactured, and it communicates with everything over the EtherCAT. So you would plug it all together, and that CIA 402 controller would take control and make everything happen. So that is one way of controlling these products without the SEW controller. Now, that said, you have to order a special profile. It's a different firmware that goes in these products, and you have to do this at order time. And I will show you when we discuss product nomenclature how this works. You've got to do this at order time and say, I want these products to work with CIA 402. If you take just a standard SEW version, it will not work with CIA 402. It needs one of our controllers in most cases. So that's exception number one. Be aware of that. Exception number two. It is possible to control a MOVIDRIVE modular or MOVIDRIVE system product directly over the SBus Plus, in other words, that built-in EtherCAT interface, if you have a PLC equipped with EtherCAT. That's usually Beckhoff products. Now, there are some exceptions to this, but here's kind of the idea here. This is a Beckhoff PLC that I have, and it could be connected up to those different SEW products. Again, you've got a MOVIDRIVE modular, you've got some MOVIDRIVE systems. Everything is connected together with EtherCAT. Remember, EtherCAT's built into all the SEW products. It communicates with the EtherCAT port on the Beckhoff, and it's taking kind of control of each axis. So this is another way of operating without an SEW controller. In fact, you can't use an SEW controller here. There are a few caveats to this. MOVIDRIVE modular double axis modules can work with this method, but you can't at this time use MOVI-kits. Those are those built-in application modules. But in the future, we are introducing a new firmware that does give some MOVI-kit capabilities to the double axis modules. Firmware 10 and higher will be different. So depending when you're watching this video, this statement that I'm telling you may or may not be true. So what you want to do if you're going to do this, and this is kind of a niche application, you might want to speak to an SEW URODRIVE application engineer, someone in our regional engineering group, and find out what you can do with the unit you have. And maybe you've got to do some firmware updates as well. So this is kind of a niche thing, but I do want to mention it here, okay? But this isn't the rule. In general, you will be using an SEW controller with these products. Little helpful hint here, just to keep everything clear. I will be using the term axis quite a bit, and we've talked about MOVIDRIVE modular being a multi-axis VFD. Axis is not specific to that product. When we say axis at SCW, we mean any VFD driving a motor. We call that an axis because it's turning things. So when I say axis, just think VFD with an attached motor producing rotary motion of some kind. All right, well, that was definitely a big gulp. I gave you a lot of information about our products, and so I'm going to bring this session to a close. In our next session, we're going to talk about the controllers and some of the other accessories that go with the VFDs. But for now, that is the end of this session, so that is the end of session number 2. See you in session number 3.